Okay, YouTube, in the last couple of videos, we've looked at the basic patterns and shapes of the sines and cosine curves and talked about their anatomy with respect to their amplitude period and how we determine those from functions. I suppose that we could write one here of the form like this. So we have a sine bx, we'll say minus c plus d, or we could say y equals, let's go with a cosine bx minus c plus d. But functions of this form, and what we're going to do is going to kind of formalize how we put this into a frame when we use this framing method of graphing, and how we could use all that information we were able to determine in the last video to construct our frame in the first place so that we can always make our graphs accurately. So kind of a formal process. So we're going to start with this. Basically, how it all fits together. Recall that with your sine curve, say, it starts at, it's 0, and then it goes to its maximum, and then it goes to its 0, and then it goes to its minimum, and then it goes to its 0. You can see how this kind of, already fits into this frame right here. But with respect to our sine curve right here, basically, we said that it had parts to it, including the not the anatomy, but the amplitude of the graph, the amplitude. And we say that traditionally the parent function, the amplitude, is 1, but the amplitude in general is half of the distance from our maximum to minimum value here. And so informally we could say it's this distance that it goes above or below what we call the midline of the graph here that you see that splits down the middle of the frame here. So our amplitude, really importantly here, is the height of the frame. And so I suppose that we'd want to make a note of that here. We'd say that with respect to our frame, we'd say frame, its height is the amplitude of the graph. So we say equal to the amplitude. And let's recall here that the amplitude of the graph we said is the absolute value of this a value from this leading coefficient here. With respect to the length here, and you can already see on my diagram, the length of this frame is just the period of our graph here. And we say, so we say the length is the period of the graph. And it's not always 2 pi, but we say the parent function, we say is 2 pi over b. Is our way of remembering this here. But basically, it's the normal period is 2 pi of a sine graph. And we're splitting it up amongst b cycles here. So with respect to how these frames look, let's remember though, the sine curve always does start at 0, and then it proceeds to its maximum, and then to its 0, and then to its minimum, and then to its 0 again. And so if we have a positive a value, we have this traditional sine curve. Now, before I construct any of these other frames, one thing that I do want to mention here is with this first sine curve. We say, notice that I've kind of highlighted 5 critical points here. So as we construct our frames, the height is the amplitude of the graph. We go above and below by the amplitude, and the period is just the length of the frame here. But with respect to the frame itself, this graph has 5 critical points, and in order to kind of find those, what we do is we always split up our frame lengthwise right down the middle. And then what we do is we also take this frame and we split it in half. And I say in half, and you notice 4 partitions here, because I'm going to say we split that in half and we split the halves in half. And that's really kind of an important concept, that we have it and then we have the halves. But basically, we allow ourselves to do this in order to come up with these 5 critical points. And you can just see that these 5 critical points, zeros occur at the midline here of the frame, and then maxima and minima occur at the top and the bottom of the frame respectively. So our graph of the sine curve with a positive a value looks like this. Let's go ahead and let me put that back there. The graph of the sine curve with a negative a value is just reflected over the x-axis, and so it's going to proceed down to its minimum first, and then to its maximum. So we have our minimum stop, and then our maximum stop. Ooh, we can make that better. So with respect to cosine, recall that cosine of 0 is 1. With 0 radians, our x value is 1 on the unit circle. So we say it starts at its maximum, then goes to a 0, then to its minimum, and then to a 0, and then proceeds back to its maximum. So it's kind of like this U-like graph, and that's kind of how I always remember it here. And it kind of does flatten out at the ends there, because you got to understand that it's really just going to repeat itself indefinitely. But with respect to a negative a value, we would start at our minimum and then go to a 0, and then to our maximum, and then to a 0, and then proceed back to our minimum again in our frame. So our job basically is, hey, can you construct a frame? Because otherwise, if you can, we can just fit these graphs right into their frames. You can't get them wrong. So what we're going to do is we're going to look at what we call the framing method. And it's just kind of a procedure to go through when you want to make this graph. I'm going to lay it on you here really quickly, though. We basically say that you need to find the amplitude and the period of the graph, as well as the starting point, and we'll go into the starting point in this part of the video here. But basically, if you do that, you can construct any graph from your frame. So in order to do this, what we're going to do is we're going to say that we always find that starting point first. And so with respect to our amplitude, let's go ahead and list these things again here. amplitude we say is the absolute value of our a value here on our function, and our period is 2 pi. With sine and cosine it's 2 pi, but we split it up b ways. So we say here's our amplitude in period, okay? But with respect to the starting point, what we want to do is we want to note that the starting point, remember that the starting point is at the point c over b comma d, where c is a dishonest value. I only say that because it's, you know, if it looks negative, it's really positive. If it looks positive, it's really negative. So what we're going to do here is that we're going to find our starting point, and then from there, really what we're going to say is, well, knowing the amplitude and period, from this starting point, we could say we know how far up and down to go. We can construct the left side of this frame. And with the period, we could say, well, then I know how far out to go to the right here. You know, from there, I have this period length. And from there, you can see that this is just a rectangular space. So now we have the outer edges of the frame. What we're going to do is, of course, split this down the middle and then split this half, split those halves in half. And, you know, we'll put this all together. But basically, that's the gist of it. Then we'll just fit in the basic shape of our graph here. So you'll notice here that once I say that you have your frame, we will sketch the graph here. Determine whether or not we have a reflection. If our a value is negative, okay, then we have a reflection. So we say a negative. I'll make a little hyphen here. A negative just means that we have an x-axis reflection. Recall that that would do that to our graph here. So let's put this together. I want to do this here, labeling all 5 critical points and stating the domain and range when we're finished. So looking at our first graph here, I think that it's just really good practice before we do anything here to just kind of determine the values of a, b, c, and d within our function here. So our a value, this leading value out here, looks like a -1 must be our a value. Now our coefficient of x, I don't see anything there, so it also must be a 1. Now our c value, notice that our c value looks like positive pi halves. Really, we have a negative pi half c value there, and then our d value, our vertical translation, is just a +3. So with respect to making this graph, let's go ahead and do these things right now. We're going to get the starting point, we're going to determine the amplitude, and we're going to determine the period of this graph here. So the starting point, let's go ahead and start with that. We say it's c over b. So we have negative pi halves over our b value, which is 1. That'll make that easy. And then we say comma d. So our starting point really is just negative pi halves. And then 3. So this graph is really going to be shifted left pi halves and up 3. And then we say it's amplitude. Well, the amplitude is the absolute value of a. And we know that the absolute value of a number is always positive. So our amplitude is 1 here. I'm going to put a box around these things. Let's put it in a different color. Starting point, amplitude. Now the period, we say the period is 2 pi. It's normal period split up by b, which is the number of cycles we'll go through. So since this goes through only 1 cycle, looks like here with our b values 1, then we're going to have a normal period of 2 pi. Put a box around this. So now here comes the graphing part. The thing is, we always want to start by graphing our starting point first. And when it comes to graphing these trig functions, I always say make your x-axis a little bit longer than your y-axis, most likely, because we're also often going to put in more than 1 cycle of this graph. So taking a look at this, the first thing we're going to do is we're going to find our starting point, which is this negative pi halves comma 3. Just means that we're going to find an x value to the left here that we're just going to call this negative pi halves. That's what I'm going to call that. And then what we're going to have to do is proceed up 3 units on the y-axis here, but we're going to put a little, I'm going to put a box. I want to put a dot because I don't want you to think that because this is the starting point your graph goes through it. It doesn't have to. So with what we have graphed here, the thing is we needed the amplitude and the period. I'm always going to start with the amplitude. Amplitude tells us the height we go from our starting point. So because the amplitude here is 1, we're already at a height of 3 here. It means that our maximum y value is going to be a 4 and our minimum y value is going to be a 2 on our frame. Now I kind of want to keep those out of the way. So how about I put a 4 here and I'll put a 2 just underneath here. But what we're going to do is we're going to go above 1 and below 1. This is the left side of our frame. Now with the length of our frame, what we're going to have to do is we're going to have to say that we're starting here and we're going to have to go out 1 period length. We say period length. So our period length, which is the length of the frame, you'll notice that our period length here is 2 pi. So you would think that we could just put an x value here and we could call that 2 pi. I'm telling you, you can't do that. What we have to do is we have to say that's 2 pi plus the original x value of negative pi halves. In other words, we're going to start at negative pi halves. We're going to go 2 pi units past that, but that doesn't mean that this x value is 2 pi. It means it's the original x value plus the 2 pi that we had to begin with. So we are going to have to do some pencil work here, a little bit of scratch work. I'm going to put an x value there though. So let's do this. We say negative pi halves plus 2 pi, which would be 2 pi wholes, which would be the same thing as negative pi halves plus 4 pi halves. So we get an end value of 3 pi halves. So we're going to label this 3 pi halves, and we're going to extend our frame. I kind of like to put dotted lines here, out to the right side here, where it would then drop down, and this would be our frame outline. Now, I wish I would have spaced out my y-axis a little more. Just know that you can do that. But with respect to our frame here, we already have half of what we need. I'm already going to construct my midline, as a matter of fact. So once you get this in, we have the height here, we go above 1, below 1. We're going to now split this in half. So we're going to start with this here. We're going to split this in half and say that this x value right here we need to know. Now the interesting thing is that this x value right here is the average of these two x values. And the nice thing is the average of any two numbers is their midpoint. So if we took negative pi halves plus 3 pi halves, we're going to do this here, and we're going to divide by 2. Really what we get is, I suppose, 2 pi halves on top over 2. And this 2 pi halves really just becomes a pi. So we get pi halves. So this must be the x value, pi halves here. And it would make reasonable sense that if we were to now split this in half this way and this way here, we would have an x value here and an x value here. And the average of negative pi halves and pi halves is 0. And you can see if we were counting by pi halves here, this would be 2 pi halves, or the same as pi. So now that we have this frame constructed, here comes my favorite part of this video. We can just fit our sine curve in here. And notice that we are graphing a sine curve. So with respect to a sine curve, I want to notice here that A is negative. A negative means that we have a reflection. And so we're going to start at our 0. We're going to start at 0 at the beginning of our frame. And we're just going to put in our reflected sine curve, which is just this graph right here. Okay. And so we could dip below and above and above and below. And here's our sine curve. You notice it has an amplitude of 1. You notice that it was shifted left pi halves units, which was just described here in its function, shifted up 3 units to begin with here. You can see that everything shifted up 3 units, and that it is reflected. So let's try this again. I'm going to try this again with the cosine curve here. And I want you to try this before I kind of dig into it. You can just pause the video here, but identify A, B, C, and D. And find your starting point, amplitude, and period, and see if you can construct your frame. But for right now, if you're just playing, man, let's do this. We say A, B, C, D. We'll identify these values. We'll go a little bit quicker here. A is 2. B looks like is a transcendental value, pi. We have a C value of negative pi thirds and a D value of negative 2. So we're going to put this little index over here. And we say that, well, regarding what we need to know the starting point, the amplitude, and the period of this graph. So the starting point, we have C over B comma D. Now, with respect to C over B, we have negative pi thirds, and this is over our B value here, which is pi. This is going to take a little bit of work on this one here, over pi. And then we say that our D value is negative 2, so we're going to be shifted down 2 units. Now, with respect to period, we say it's 2 pi over the B value, and our B value here is pi. So this is going to make this a little bit easier. We say that our period is just 2. Kind of nice to just have a whole value like that. And then, oh, sorry. Better put that under period. I actually got a little ahead of myself there. We say 2 pi over B over pi. Period is 2. We need to find the amplitude. But hey, the amplitude is just the absolute value of our A value here. So we say the absolute value of 2 is 2. Amplitude's 2. So with respect to simplifying this value here, let's go ahead and I'm just going to carry it up over here and do this work. We say negative pi thirds divided by pi over 1 is the same thing as negative pi thirds times 1 over pi, multiplied by the reciprocal. And so you can see that our pi's cancel out. We get 1 and 1 here. So really multiplying straight across, we get negative 1 on top, and on bottom we get 3. So we have negative 1/3 for our starting value. I'm going to write this down here. Negative 1/3 comma negative 2. So interesting. When we construct this graph, let's see if I space out my y-axis a little bit more here. We're going to go left 1/3 and down 2. So let's see if I can envision this here. If I go left 1/3, I must not be going left very far. So I'll call this left 1/3. And if I'm going to go down 2 with an amplitude of 2, I'm going to go 2 above and 2 below. I better go down to like at least negative 4 here. So we would say that if I go down left 1/3 down 2, here then is our starting point. But this is negative 2 here. So constructing this frame, we need our height. Now the amplitude being 2 means we're going to go above 2, below 2. And with the length of the period being 2 here, what we're going to have to do is we're going to have to take negative 1/3 and add on the length of the period, which is negative 1/3 plus 6/3, so we get 5/3. So we're going to pick an arbitrary point on the right side here, and we're just going to call this 5/3. I suppose it's just however long we want to make our frame. I'm going to make it a little bit shorter this time. We say 5/3. And so we'll just go ahead and extend this frame out to the right from that left side. Here's our frame. Now here comes the splitting, and we say split it in half. So I'm going to pick this point right here, and I'm going to find the average of -1/3. So -1/3 and 5/3. We're going to divide this in half. So we would really get, I suppose, 4/3 divided by 2. This isn't the most fun thing to do in the world. And really that's the same thing as 4/3 times a half. So we really get, cross-reducing here, 1 and 2, 2/3. So this must be 2/3 right here. So now we have to do halfway between 2/3 and -1/3 and halfway between 2/3 and 5/3. So we'd say let's do our 2/3 and 5/3 first. Let's just add these together. We get, I suppose we get 7/3. And if we divide that in half, same as multiplying by a half here, we're going to get 7/6. So this is a necessary step. We'd say that this is our 7/6 x value mark here. And then when we average -1/3 and positive 2/3, we get -1/3 plus 2/3 is a single third. And when we divide that by 2, I'm going to say forget all this now. We say divide this by 2 and multiply by a half. We get a sixth. So a sixth would just be barely on the right side of 0. We say this is a sixth here. Okay, so good news, everybody. We've got our frame constructed here. Here's our midline. So now the only thing we have left to assess is what kind of graph we're making. It is a cosine, so it is a U-like graph. It does start at its maximum. And I say starting at its maximum because we say since our A value is positive, it is not reflected. So notice this. It does start at its maximum. It doesn't go through the starting point here. That's just to help us make our frame. So we'd say goes to its 0, goes to its minimum, goes to its 0, goes to its maximum. And so here's just one cycle of our cosine graph. Be prepared to tack on another cycle if we need to. Cheers.